All right. Hi, everyone. Thanks again for joining us today, and welcome to the virtual Canada user group. For those of you who were originally signed up to attend our in-person meetings in Toronto and Montreal this week, I appreciate your flexibility as we're doing our best to manage the current health concerns. So hopefully we will be back with you in person very soon. And I also want to take a minute to call out Vancouver, Ottawa, and Quebec City for any virtual attendees we added when we decided to make this a Canada user group. So thanks again, everyone, for joining us. Before we get into the meat of the presentation, I just want to run through a few logistics. First of all participants are muted. You may ask questions using the Q&A panel, which is at the bottom of the GoToWebinar applet. Our team will provide you with answers during or after this presentation today. If you are experiencing any connection issues, please also use the Q&A panel to communicate those. This session is being recorded, and all registrants will receive a link, a copy of the slide deck once it is live. You can also find a PDF version of the slide deck in the handouts portion of your GoToWebinar panel. Ben, if you can jump to the next slide quick. So the last topic I wanted to address before I hand the presentation over to Ben is the community website. For those of you who aren't familiar, just wanted to quickly call attention to the community website. It's a great resource. In addition to the user groups, it's a great resource for to ask technical questions or to interact with other community members. And with that, I want to introduce to you Ben Hough, Talend Solutions Engineer, who will share with us about Talend Cloud API Services. So with that, Ben, take it away.
Yeah, hi everybody. My name is Ben Hough. I'm a solutions engineer with Talend. I'm going to talk about Talend's API services offering today, and so we'll get right into it. I do have a few slides to really give an introduction to the Talend framework and what exactly we do. All right, so the most important thing to understand about Talend is the fact that we cover many different integration disciplines. So whether you're talking about ETL and data quality types of requirements, we of course cover those very well, or you branch into big data needs, so running in a Spark cluster somewhere like Databricks or whatever flavor of Hadoop you might be using. We can work in that space and run natively inside of those clusters, and we can also cover application integration needs, whether that's creating and publishing REST APIs, or it's handling robust messaging scenarios where you need to do message routing and types of real-time event-based processing. We're going to focus mostly on APIs today. Okay, we are cloud portable. There's an icon up here about cloud integration, but really it's just there to signify that we can run in the cloud, we can run on premise. Our cloud platform allows you to do both of those things as well, and we'll cover a little bit more of that in the architecture portion of this. And then beyond that, we have self-service applications covering data preparation and data stewardship, and branching into more things as time goes by. So we allow for a business user window and access into the ecosystem of integration and connectivity between your applications and data stores, but still governed by IT within your platform. So that allows for facilitating those needs without formation of a shadow IT within your organization. So there's a lot of value to that. All right, so we're going to focus on API delivery with Talend. And what I mean by that is we have 4 phases of the API development lifecycle that we cover. Design, so creating an API documentation, a specification document to cover the design of an API. Implementation, so building the actual API that's going to run and assigning, where do you get the data, how does a query work, all the different details involved in actually engineering the execution portion of that API. The test phase is all about making sure your API is operating as designed, as intended, and also can be automated as well. Sometimes you need to automate tests for either regression or to validate that a deployment was successful into an environment. So it's really important to be able to automate that part. And then operations, so meaning deploy and run. How are you going to deploy and run this? So we cover all 4 of those phases of that API lifecycle. I do want to mention that API gateway is not in this in the supported circle, right? It's not in the supported features that we provide at this time. So if we're happy to plug into whatever gateway you want to use, and we found that in a lot of cases the gateway has been commoditized. So for instance, if you were deployed into Azure, then you're probably going to end up using the Azure gateway to have it, for your APIs. Same thing with AWS. You'll use AWS's gateway or API management, which includes their gateway. So beyond that, on-premise, if you want to use an on-premise provider, then we can plug into those as well, because we have a standard-based documentation support for Open API specification. Okay, so hopefully that provides a perspective initially on our different coverage and scope of how we support APIs. And we're going to get into the details. I'll walk you through each one of these. Okay. So within our API services platform, we have those 4 different phases here. We have API Designer is the product that covers the design phase of the API. We have Talend Studio, which is the implementation side of things. It's the same studio that you can use to create ETL jobs and data quality jobs and so on. And we're actually going to access the same component set and design canvas to create an API, or I'll show the API that's created already. The API Tester covers that testing function. While the designer itself on the top left, the designer is a cloud application. It's hosted by Talend and so on. The tester, however, is a plugin into Google Chrome. So there are other testers out there, but this one is integrated into the Talend platform, and you can automate those tests. Like I mentioned, this is part of your kind of CI/CD workflows. And then finally, for operating, we can deploy and run that API in your environment using our Talend Management Console. So the example that I'm going to walk through to show all of these features is called the Student API. The premise behind this API is that we have a bunch of core student data that's in disparate applications. And that data has been gathered together and run through data quality to standardize, validate, deduplicate, curate that data into a central trusted data store. So now as an organization, what this higher ed organization wants to do is expose that data to various applications through an API, so that, for instance, some applications over here like scheduling, grading, e-commerce, maybe a student app on their phone would be able to access it and get information. So that's the kind of a scenario here, publishing trusted data that's been curated through Talend's ETL and data quality capabilities. So getting into the first phase of that, designing this API, looking at the design first methodology, what we can do is have multiple collaborators work on that API contract, that API design of what is the API supposed to do, how do we want to expose this functionality, and from a technical standpoint, what's a good approach to do that as well through the contract. And so that can involve multiple different stakeholders, both technical and non-technical. You can have business users in there saying, hey, my application really needs to be able to do, X, or needs to have access to certain information. And so they can help drive the business functionality as if you're building a business API. And out of that process comes the contract. This is going to use Open API specification. And from there, you can use that as a kind of a guide to create your implementation, your testing, and it will also produce your documentation for you. Okay. So getting into that, we're going to look at Talend API Designer, and this is going to fill that need. So we're going to talk about visual API contract definitions. We're going to talk about automatic API mocking. So we're going to be able to mock up this API before it's even created. And I'll show you how to do that. And then of course, the documentation. Do you want to host it? Should we host it for you? And how you might want to export that. So I'm going to jump out to the Talend portal to take a look at this. And this probably needs to be refreshed for my session here. Bear with me a moment. Okay. So if I go to my Talend portal, I have a bunch of different applications here pertaining to what I can do. And that could be Talend's Pipeline Designer, which is a web-based UI or a web-based development environment for creating, today anyway, fairly basic ETL jobs. And we have Talend Data Preparation for data prep needs and data stewardship, and those are mostly business user focused. The Management Console, TMC, that's where you can create, you can schedule jobs, you can deploy an API, things of that nature. So it's for operations and administration. And then Talend Studio is the development environment I'm going to jump into, and I'm going to show you the implementation side of things. Right. And beyond that, we have access to our API Designer and Tester tools. So I'm going to launch the API Designer. And my last API I was working on is this student API, so it brought it right up for me. So here I have access to work with the configuration in here and tell it, where are the endpoints where this API is going to be published, what kind of security schemes do I want to add to this, what media types does this API support, could be multiple types, of course, and just general documentation, whatever I want to type or paste into here to talk about what exactly this API is supposed to do. I can go in and create individual requests, and of course they can cover all kinds of different HTTP verbs, get, post, put, delete, patch, and so on. And this one in particular is a get, and it's got a bunch of request parameters here. And I can go in and define these request parameters very easily. So for instance, if I wanted to look at entry term, this is a specific number with a year and a term number in there. Maybe I need to go in there and add some examples to say, if you're in a 2020 term, you might have a 01, and it might have a 02, and 03. Okay, I've just typed them into the UI. Obviously, it's very easy to do, and it added them in for me. So now I've just added these examples to my documentation, and when somebody comes to look at and figure out how to access or use this API, they'll have access and see all those different things in the doc. Okay. Another example here is an enumeration. So instead of just examples of what someone might send in, these are the specific values that are actually accepted. Right. So here I have for applicant status, a student applicant, right? If this would be either accepted, denied, withdrawal, or enrolled. And it's got exactly what's expected in the API as a query parameter, so there's no guesswork involved. So you can see there's a lot of value here. Having a documentation like this and understanding what's expected from the API versus, kind of trial and error or trying to find some resource with an example somewhere when it's not explicitly and simply in the documentation. So if I continue to scroll down, I can add things like headers to this, special custom headers. I can add multiple responses. What I've got here is a 200 response for what it's going to look like in JSON. And I've got an example pasted in here. I could also provide multiple examples. And I'm also pointing to a distinct object that I defined as part of this API design. So I've got this student object, and it's pulled out all the different fields out of the JSON for me so that I can individually document each one of these fields as well. Just like I showed before, you can go in and add in all kinds of information about it. Okay. It can also be a complex type. So I've got my applicant status here as well with my enumeration of accepted values. So you can reuse these pieces in your API design. Okay. All right, so what I can, some other things I can do with this, if I go into settings, go ahead and save that. If I go into settings, then I can expose this documentation. And if I click on this, it will show me what it looks like when I publish this documentation. It's very clean, very straightforward. If I need to navigate, I can go to the different pieces of this API and see the documentation. All right, so it's very easy to understand from a developer standpoint or whoever's going to consume the API. I can also set up that mock endpoint that I mentioned. Just by clicking this button, I can enable this mock endpoint, and then it's going to give me an address, generate an address for me that I can use and call in and exercise this API, or the mock endpoint anyway. It will return examples out of my documentation as a response and just kind of behave as if it is the real API as much as possible. So that's great to know if you have a client, as a developer, it needs to build a client that's going to use the API. At the same time, the actual API is being built. This can really accelerate your development time and provide a lot of acceleration there, a lot of value. You can also plug this into GitHub so that you can share these APIs across multiple accounts, share the documentation, right? You can also password protect, say you want to publish it, but password protect it. You can do that, or you can make it just completely public or just accessible within your own team that's working within Talend. Okay, so that was the API designer. Implementation is all about building the actual working pieces that are going to execute and compute and do all the lookups and things of that nature. This is going to use the same development studio as Talend's ETL capabilities and other capabilities, as well as data quality. So you can actually use components that you might otherwise use in an ETL job to build your API. So let me bring up my studio. So the first thing I'm going to do when I have an API that I need to implement is that I'm going to go to my metadata repository in my studio. And this is where I can drag in connections to databases and bring in metadata for tables and views, or delimit or XML or JSON files and bring in the metadata for all those different things, as well as business level applications like Salesforce and Marketo. Of course, things like Snowflake and other types of databases are supported here as well. But for REST APIs, there's also a REST API definitions portion where I can go and retrieve that API definition from my designer, and then just go ahead and ingest that API. Once I do that, it's available here as an item on my metadata list, and I can just drag it and drop it onto the canvas like I did with this one. So at that point, what's going to happen is it's going to generate a component that's pre-configured with all the particulars of that API metadata. So here I can see it's connected to my repository, and it actually lists the, you can't see the full word here, but it actually lists that it's connected to that student API. And down below, all the different request pathways are defined here. So for instance, get by student ID. This was generated for me and it matches my documentation. If I go back and I look at my request pathway here, get by student ID, it just matches exactly what you have in your doc. And so at that point, you can define what pieces of metadata or what fields, what data you expect to come across. So here I have an ID that I expect to come across as a path parameter. And I can see that the path parameter is inside of my URI pattern. So it's expecting the actual ID value to be inside of the web address or HTTP address that's used to send a request here, right? So in the meantime, it's going to receive a request, and each one of these pathways, it covers an individual request pathway, each one of these. So for a given request, let's say I'm going to go and get by a student ID, it's only going to travel up this one pathway, do that processing, and return the response. If I'm going to send in a delete, then it's going to go down this bottom pathway and execute the delete against the database. By the way, this is using MySQL. It could use any number of database providers, and we pretty much cover them all. Okay. In our component palette of about almost 1,000 components. So if I want to test this API, what I'm going to do is I'm going to set this up to connect to my database with my configuration properties with the right database, and I'll go ahead and click Run. And what that will do is it's going to take my drag and drop design, and it's going to break it down into Java code under the covers. I don't have to write any Java, it's just based on the drag and drop components. And instead of generating the code, because we do the same thing for ETL jobs and write procedural Java code from those ETL jobs that are also drag and drop. But when you're using a REST API or even the SOAP version as well, it will generate the Java specification for that technology. In this case, it generates a JAX RS interface under the covers, in case that's a relevant thing for you, and it will encapsulate the relevant code within that JAX RS spec. So the point is that this isn't just an ETL engine with API connectors cobbled on the end of it. It is generated from the ground up as a RESTful web service and not as an ETL service or ETL job. So I do want to emphasize that this can be very high performance, assuming you don't have a bunch of bottlenecks inside your service and so on. All right, so now this thing is running. I can actually go out and I'll run some tests on it, but before I do that, I want to just quickly cover a couple of examples of the processing that I'm doing inside this API. So on this top pathway, I've got this path for get by student ID, right? So I've got a student ID coming in. It's listed right here. It arrives on my request. And then I'm joining it with my lookup information. So I've got this, this lookup table that's being queried and is bringing in the data. And that's pictured up here at the very top. And so what I have here is this ID. I'm also getting the value of this ID, and I'm going to inject that value into my SQL statement so that I can craft my query. And so this ID, I'm pushing down into this, what we call a global map, just a key value pair that allows me to use this value in other places and other components in my design. So I've got this thing stored under student underscore ID. You can see it right there. So if I hit cancel here and go and look at my lookup, my component tab, I've got this thing configured for my table. It's aware of the schema and it's generated a basic query select statement, but it's also got, I added this where clause at the bottom so that I could narrow it down to the specific student ID that I need for a given request. And so this is what that looks like. I'm injecting that into this query and it's able to just get the one record by ID each time. So you can inject all kinds of things into the query. This is simply just a free-form SQL query if you want to craft it that way. You can actually compose the query dynamically if you want to. So there are a lot of options here. It's very, very flexible, and you can overwrite all of this if you want to. So I do want to emphasize that it's very flexible on the kind of database interactions you want to do. Okay, so finally, after this lookup happens, so we now have a record over here, it's going to send that data. This is just drag and drop mapping, right? So it's going to send that data to this outbound basic structure. In this case, it's going to send it out as JSON. It could also send it out as XML if you told it to. And then down below, I'm also supporting an error message that if I'm not able to retrieve anything, it's going to go ahead and send a message that says, hey, I couldn't find that student, and along with a 404 code saying it's not found. Okay, so this is just set up to do that by saying, you know, if you failed to do your inner join on the left side, that's what this property is, catch, lookup, inner join, reject. That's what's gonna cause it to send this out. Okay, so as you can probably imagine at this point, it's very flexible. You can add many different output options rather, as far as how it's going to respond. So you have the flexibility to design as you need to according to your requirements. One other thing to highlight here before I show the tester portion of this is that I'm using data quality components, which we have an entire suite of data quality functionality available to us here. I'm using this to do a fuzzy match. So I've got an initial lookup with a little bit more properties in the where clause, and it's got a couple of properties like application status and entry term that it's querying on. But everybody that comes back, it's going to do a fuzzy match on the names that are provided there. So I'm kind of providing a little higher level of functionality here than just, you know, standard, you know, lookups, fully validated or exact match rather is what I'm looking for. Exact match lookups that are usually what are used in this case. So I went ahead and provided a Levenstein fuzzy match, but I could change that to one of the other algorithms here. So my point is that our data quality functionality, whether it's data masking or fuzzy matching types of lookups, standardization, some validation capabilities, that you can actually embed within your service and not just in ETL style jobs, and provide, just very easily provide a higher level of function within that. Okay, so here I have my service. It's running inside of Studio for now, just to do a quick test on it. And if I open up my my browser, I can now open up my API tester application. I'll go into my requests, and I've actually got some defined requests here to test out this API. I can also access this through my Studio. I can just say, hey, just open this in tester, or I want to go back to the documentation or the designer, and I can easily get from one place to another directly off of this convenience link. Okay. So if I want to go ahead and test this, I've got my Studio environment up. I could have it deployed to dev, stage, production if I created those environments. I could test against those as well if I had them. But I'm going to keep it on my Studio environment, and I'll go ahead and send in a request. And that gives me back, you know, some result set. I can browse it, of course. It's pretty standard functionality there. But I can also set up assertions on how I want to validate the response of this test. So if I add an assertion here, I can say, you know, get me, you know, the duration of how long it took, or, you know, some content of the body, or a header that it came back, or something else here. And I can add in an assertion that checks, you know, to make sure things look right in that response. And it will, you know, turn red and tell me about it if it doesn't work, if the response doesn't match that assertion. So that's one request, and that's fine. But what if we need to do a series, execute a series of API requests that are related to each other, and maybe even use information from one request into the next request? So for instance, if it returns a property, I need to add to the next request and send that in. Well, for that type of a need, we have what we call scenarios. Scenarios are exactly for that. If you need to execute a series of requests whether it's to the same API or to many different APIs. It doesn't really matter, but you can execute a series of requests as a unit and provide that as kind of a a unit of work within your testing setup. So if I click play here, it's going to run through requests to my service. It took about 2 seconds in this case. Probably be quicker if I go again. Yeah, about a second. So it's executing all 4 of those requests in sequence, and what those do in this case is to add a brand new student. Step 1 is add a student. Step 2 is get that student using the ID of the student. Step 3 is to delete that student, and then step 4 is to try and get the student one more time and just verify that you cannot retrieve it because it was just deleted. So those are the 4 steps here. If I drill down, I can see some details here. Here's my JSON I'm sending in, and I'm expecting a 202 response out of that. Okay, it's pretty straightforward. The next request gets a little more interesting. So my next request is to get the student, and I need the student ID up here in the path. And what I'm doing is sending in this, using this expression to use the student ID from the previous request. And so building that expression is really straightforward. So if I open up this expression builder, I can browse to that. So if I go in the student API, in my scenario, in that first request, in the body of the request, I have the student JSON, so that I'm into JSON now, and then I can grab the student ID. So it just built this expression for me. As you can see, it's very easy to do, super straightforward. And then I've got a preview of what the value is. Okay, so all I do at that point is click insert, and that's how I got this expression to show up here. I don't have to know any syntax. I don't have to remember or have a typo or something. It's all very straightforward. So it went ahead and used that number inside the request path. It could also go into the body or somewhere else, into a header or something. And then in the assertions, I'm also doing a validation on the JSON body itself. So for instance, I've got the student object that's coming back, so because I'm getting the student object, and it's listed here, but I'm also validating against the student object that I sent in the previous request. So this JSON that's in the previous request, I use the same expression builder to go and select that, and is validating the entire object against between each other. I could have this set up in a more granular way to validate individual fields or check if something's empty and things of that nature, but this is just a basic validation against the whole student object. Okay, so beyond that, we have running a delete on that object, and then finally expecting a 202, and then finally we're trying to get that object one more time, that student record, and it's returning a 404. So I can't find your ID that you sent in. And that's the test pass because that's what I want to see. Okay. Okay. So we talked about the implementation, and we talked about the tester, where we went through a scenario. We had some test assertions. We talked about the wizard. This can plug into continuous integration, continuous deployment frameworks. So if you're running Jenkins or TeamCity or Azure CI suite, or I forget the name of the Azure one, but all the different continuous integration and deployment products can pretty much plug into this without a problem. Our build itself is also Maven based, so you can actually build the service here in the studio. You can build the service using continuous integration, using our Maven build, and you can automate the deployment of that service into your target runtime, and then run that tester to make sure it deployed properly as one whole workflow and automate the whole thing. So that's it's pretty nice to have if you have a continuous integration initiative or workflow in place. Okay, so I'd also like to mention that the UI, it will show, intelligence on which pathways were taken based on your interaction there as well. Okay. Okay. So about the architecture, we're going to cover architecture and a couple other points, and then I'll jump into questions and see if you guys have any questions today. So for architecture, Talend Cloud allows you to deploy your services, any orchestration routes, or as well as batch jobs, ETL jobs as well, in the servers that you want to use them inside of. So usually you're going to have a VPC or an on-premise environment or something where you have a local resource you want to connect to, usually a Oracle or a SQL Server or MySQL or something, some kind of an application database that you want to kind of service enable or leverage, and we allow you to run local to those resources. Our engine, or not engine so much, but our agent that will run inside of a VM, or a server inside of your environment. We call that the remote engine, and that is what stays in contact with Talend Cloud and allows you to deploy and manage your services and other artifacts within your environment. So it's just a client, or rather an agent that will keep status updates and logs that you're logging out from your service or whatnot, and it will bring it up to Talend Cloud and allow you to monitor from Talend Cloud's interface. Okay, you can have multiple remote engines out there, and you can kind of set them up in a cluster, and you can actually either deploy your service out to the cluster, or as well for batch jobs, ETL style jobs, you can have it run dynamically on the most ready server, the most available server to run that workload. So those kind of load balancing, high availability type features, we help you do that by controlling that deployment. Talend Studio is what I've been working in this whole time, most of the time, where that's the thick client. It goes on either on your developer workstation, maybe a laptop, or what have you. It can also run inside of a VM. So let's say that you have an EC2 server and you just do a remote desktop to that, and you use that as your workspace, your workstation. You can certainly do that as well. But that is definitely a thick client that you download and you use, and that connects to Talend Cloud. So meanwhile, Talend Cloud will manage things like the projects that you have available, the roles of your different users. So which users have access to which project or to which portions of the Talend platform. It's all very role-based, and you can manage your environments there as well. So for instance, if I bring up my Talend management console and I go to my environments, yeah, it's got to refresh the session here. There we go. If I go to my environments, this is where I can define, here I have dev, QA, production, and so on. I can also set up workspaces within those environments. So here we have enterprise analytics. This is a workspace that's inside the dev environment. I can have jobs and services assigned specifically to that workspace, and I can even have a remote engine assigned to that workspace or just to the environment. And we can help manage promotions between these different environments through continuous integration. So everything here is driven by an API on top of Talend Management Console. So you have access to automate all kinds of things, whether it's scheduling, deploying, promoting things, and so on. Even creating remote engines, you can automate that as well. So this is where you would manage those things, as well as your users and your projects. So for instance, if I have a project here that I need to have access to, I've got this project here at the bottom. It says, okay, here's your address, or here is the Git URL or Git location that you're using, and by the way, as far as collaborators are concerned, here are all the collaborators that you can use that are assigned to this project. You can also have groups. So if you have a group of developers, maybe certain teams that you want to assign, you can say, okay, this whole team can use this or work on this project. And from there, you use the management console to go ahead and deploy that. I've got a slide coming up on that. Okay, so that's that Talend Cloud interface, that central, hosted location that you can manage everything, but your actual deployed artifacts will run inside your remote engines, inside of your environment. So it's important to note that your data stays with you. In this scenario, we do not bring any of your data into Talend Cloud, only the things that you've explicitly logged as part of your design. And you can even have those logs redirected if you want to go keep them inside of your environment. Okay, so I think it's important to note that we don't, your data doesn't leave your network unless you have it, specifically set it up that way. All right. Okay, so from a deployment topology perspective, we have a couple of different options on build and deploy. You can either build something as a sort of a deployable into our runtime. So that would be kind of an application server style approach, like as if you're deploying something into Tomcat alongside of a bunch of other things that are deployed there. We use Apache Carafe, but it's the same kind of an analogy here. You can also build them as microservices, meaning just a standalone runnable that is self-contained with all of its dependencies. All it just needs is Java on the VM or server that it's going to run on. It uses Spring Boot to stand that up. So that's what it uses to bootstrap everything. So that can be deployed. They can be deployed as microservices as well, and that's all can be managed from Talend Cloud. You can also just get a hold of the jar itself, build the jar, and take the jar manually and deploy it into a server if you want to as well, if you want to manage that deployment. And you can also build it as a Docker container. So if I open up my studio, and all of this, you can automate all of this, but I'll show you what it looks like manually. If I right click here and I say build job, and I open this up, I can see several options here. I can have that kind of deployable for that application server approach that I mentioned. And then you've got a couple options here. A microservice, meaning self-contained runnable jar that you can just run, or you can package it directly into a Docker repository. So it'll allow you to do either one of those. And you can automate that as well through Jenkins or whatnot, and automate that build. Okay. Now, you can today you can deploy that, say, into a Kubernetes cluster or something of that nature, and you can manage that yourself if you want to. But as far as the managed deployment part of this, where we provide the monitoring and management of the service, this is the scenario, not Kubernetes at this time, but this is a scenario where we manage that deployment for you. All right, so what that deployment looks like is essentially to go into our management console, get your workspace, get your artifact, and then you can pretty much follow the workflow through, change any parameters that you need to as far as how it's going to be deployed, or you can have it pick it up when it lands, when it arrives on the server, you can have it there. And then set up any connections, say if you're connecting to a Snowflake or MySQL connection or whatnot, you can set specific connection objects that are going to be used, and then go ahead and go live, and it'll deploy it out to your server, and it'll be running. It's at that point where if you're using a gateway, you would take your API definition and you might export it. So for instance, what we might say is, okay, I'm in AWS, I'm using their gateway, I'll just click this and it'll automatically choose, the most compatible type of export it's going to do, and it'll go ahead and export that for you. Okay. And you can send that over and plug it into your gateway. All right. So let me go back here to my slide. Okay. So we talked about Talend's API Designer and Tester. We talked about the environments, the fact that Talend Management Console has APIs on top of it. We talked about the fact that you can schedule batch jobs, although that's not really the subject of today. Manage users, role-based access, and multi-tenant for environments, and some of the monitoring aspects of it. Okay. We talked about compatibility with continuous integration and deployment, automating testing and things of that nature. Bring your own gateway scenario, so plugging into your gateway, managing those deployments. Okay, so in closing, before I get into the questions anyway, Talend is a single platform. Just a reminder that Talend is a single platform that covers many different integration disciplines. We talked about APIs today and web services, REST APIs in particular, but we can cover many different other scenarios, from standard batch ETL or ELT for kind of push down SQL, data quality, working in big data, whether it's NoSQL or Spark, and also more messaging types of scenarios like robust messaging, plugging into Kafka or ActiveMQ or something of that nature, and having a really robust and complex messaging scenario support. And we also mentioned that, I mentioned anyway, that we have self-service applications that plug in business users into the data curation effort, so that we can help improve the quality of your data and make it more and more valuable as time goes by. Data is the one of the only resources that becomes more valuable with use. So that's a really interesting way to plug people in and increase the value of your data. So what I'd like you to take away today is that we can cover API design and testing, API design, implementation, and testing. We can implement graphically with drag and drop components that are usable across many disciplines as far as integration is concerned, and we can help you manage those deployments. So let me open up the questions here and see if there's anything that I can help with. Okay. So there's a question here. It looks like it's already been answered, but I'll go ahead and answer it as well. Can you import an OAS YAML file in API Designer to use this tool to continue modifying an API definition? The answer is absolutely yes. So inside of my Designer UI, what I'm going to do is go down here and I can say import. And this is where I can, and this could be YAML or JSON. And you can import any of these standards, a couple of RAML standards, the Swagger 1.2, or a couple of the OAS standards, 2.0 and 3.0. So this will allow you to import them, and then you can export in any version that you like. So I've actually had scenarios where somebody provided me with an OAS 3.0 document, but another tool needed it in OAS 2.0 or Swagger 2.0. And I actually imported the file and then just went to export, and I said, okay, give me the 2.0, and it converted it for me. So we can definitely operate between those different standards. Now beyond that, I should mention something I probably should have mentioned earlier, is that all the configuration you do in this UI, it completely drives the generated OpenAPI spec. You don't have to know any syntax for OAS, and you don't have to go and manually type anything, have any typos. It will generate everything for you and in the standard that you need. Okay, so we're pretty much the only tool out there that will do it in this way, where you don't need to know the OAS, and you can just click and define and have a guided workflow to build that out. Okay, so I hope that's helpful. Okay. Okay, well, I don't see any other questions in the question pane. So I want to thank everybody for joining us, and I hope this presentation was valuable for you. And it looks like there might be one more question coming in, so I'll wait for that. But in the meantime, I do appreciate everybody joining. I hope this has been helpful for you. Okay, I'm gonna jump over to, I'm gonna jump back to the architecture slide for a moment. Bear with me a second. Okay, so I'll bring this up while I look at, there's a question about API lifecycle management. You know, what is it that you, how do you support the API lifecycle? How much of it do you support? Yeah, I'll go ahead and review that. Hopefully I answered the particular question there before, but I'm going to review exactly what we cover. So what we would say is that we cover API delivery. So what you have here is a Talend API Services platform. It covers the design, so creating that API documentation, open API spec. We have the Talend Studio for actually implementing the API. We have the tester for testing and automating testing. And then we have the deployment, so deploy and run the API on your servers. Those are the phases of the lifecycle we support. And then you would control next iteration, usually from the design all the way through for the next iterations of what that API is going to do. Okay, so that's the portion that we support. And then the API gateway portion of it is going to be, you know, based on your choice. Do you want Azure Gateway or AWS or Apigee or Axway or what have you? Okay. So hopefully that helps with the life cycle management of the API. So there's another question here about leveraging an API that uses a token. So I'm thinking that's an authentication token and using encryption within that. So that's really kind of two questions. And so if I break it up into two, using a token, this looks like client side here. So how to read an API having token with encryption. So that would be the client side of things, falls into our data integration or ETL capability. So you don't need our API creation capabilities for this. But if I open up, let's see, let me grab an example here. So let's say you need to leverage an API and it's secured with OAuth 2. What that workflow might look like is this. You've got this REST API client, or it's TREST client as a component. It's different than the TREST request component that was used in the other job to create the API. This is client side. And so I've got this client and I want to call a service. This is actually the main service I want to call, wherever that might be. And first I want to go and get a token. So here I'm going to go and request, in this case it's OAuth, but the workflow is pretty similar in most cases if you need to make a separate request. So I'm going to go and get a token based on my credentials in an OAuth flow. Here I'm going to extract that token using some JSON, and then I'm going to store that token inside of our global map, same global map that I mentioned earlier when I was talking about the lookup for that API. So this is going to allow me to use that token value inside of another component coming up. So then inside of my next REST client that I'm going to use to call that API, I've got this authentication checked at the bottom, and I'm telling it OAuth 2, and then I'm just injecting that token here. I don't have to remember the syntax. All I can just simply say, I can type out the label I have on this component that's recording my token, and I'll do a control space, and it allows me to just click and inject, the syntax I need to grab that token value. Now beyond that, if it's not specifically OAuth 2, then you can go in here and add a custom header, you know, and whatever it may be, whatever the API requires, and you can do the same thing right here in this value. You can compose it with multiple values and concatenate them together, whatever you need to do there. So that's what that looks like to use a client to go and access an API. Okay, so there's another question here about sort of policies around an API, like throttling and SLAs and so on. So today we don't cover in our deployment capabilities. Today we do not cover throttling, like throttling based on user and things of that nature, or sort of alerts based on an SLA. You might plug into a monitoring tool to check that and watch for that, but usually that would be handled by the gateway as it stands today anyway. So a gateway would have, you know, the main authentication and management part for which users have access, and it should be able to throttle based on policies of the gateway. Okay. And so there's another question about OAuth, and when you have, I believe it's called three-legged OAuth, if I recall correctly, where there's a user pop-up that would come up, and the user has to, you know, have a kind of another factor of authentication to say, yes, I authorize using this. Typically, that's not the OAuth style that's used with APIs. It would be more of a machine user that would do access. And if you have a business or an application user, whether it's a phone app or something else, then that OAuth flow that has them interacting with it, that's typically incorporated for the application itself, and then the application has its own kind of machine user access, or the token that's a result of that might be used in the request out to the API. So that's usually handled from the application side of things. Okay. Yep. And that would also be consistent, like say if you need to integrate, say that another question is there about QuickBooks. If you need to integrate with QuickBooks from a client side, then QuickBooks should have support for that type of request token. Usually it's a client token that's used for machine access. So you'll have to dig into the QuickBooks configuration and documentation on how they expose or authenticate using machines rather than humans. Okay. Okay. Well, thanks again, everybody. I think that wraps it up for our session today. I hope everybody stays healthy and has a great week. So we'll see you next time.